Have you ever wondered if there might be another you flipping a coin in a parallel world right now? Or if every decision you make creates a branching reality where a different version of your life plays out? It sounds like science fiction, but modern physics raises the possibility that parallel universes might exist. In this mysterious quantum realm, particles can be in many places or states at once, and some interpretations of quantum mechanics suggest that every outcome of an event could be happening in some version of reality. It's a mind-bending idea. Perhaps there really are countless hidden worlds, each with its own history. Let's dive into what science, especially quantum theory, has to say about this strange possibility. Quantum mechanics describes the behavior of the tiniest particles, and it operates by wildly different rules than our everyday experience. One puzzling quantum experiment is Schrödinger's cat. A cat sealed in a box can be considered both alive and dead at once, until someone looks inside. According to the famous physicist Erwin Schrödinger, this paradox seemed impossible in common sense terms. But some scientists realize there is nothing in the equations of quantum theory that forces the cat's fate to collapse into just one outcome. In fact, quantum pioneer Hugh Everett proposed a daring solution. Both outcomes happen, each in its own universe. In one world, the cat lives, and in another world, it dies. When the box is opened, observers in each world see just one result: a live cat in one universe, a dead cat in the other. In this view, reality is constantly branching into parallel paths. Everett introduced this many worlds idea in the 1950s. He imagined the universe splitting like an amoeba whenever a quantum event occurs. Today, the core concept remains the same. The whole universe has a giant quantum wave function, and every time something like a particle collision or a measurement happens, that wave function splits. Each split creates two or more branches that continue evolving separately. It's as if space-time is copying itself over and over, each copy carrying a different version of events. If an electron has a 50% chance of going one way or another, the many worlds picture says there is one universe where it goes left and another where it goes right. In each universe, the rules of physics play out normally, and the versions of us in those universes don't notice anything strange. We simply experience one outcome or the other. Imagine standing at a crossroads, deciding to turn left or right. According to this theory, you turn the opposite direction in a parallel world. In fact, one explanation describes a quantum multiverse, where every single choice you make, and even every tiny random quantum event, splits reality. That means there could be parallel worlds where you chose a different career path, or where you ordered pizza instead of pasta, or where some amazing or disastrous event happened differently. Every possible history that could happen does happen in some branch of the multiverse. It's a dizzying thought. Out there, in the vast multiverse, uncountable versions of you might be living out every alternate scenario of your life. This all sounds exciting, but don't grab your parallel universe travel pass just yet. Many physicists acknowledge that these ideas are speculative. The many worlds interpretation is mathematically consistent, but it has some big challenges. For one, it is essentially untestable. We cannot communicate with or observe those other branches, so there's no way to directly check if they exist. As science journalist John Horgan notes, many worlds is not really falsifiable, meaning it doesn't make predictions we could go out and test to disprove it. In fact, physicist Paul Sutter points out that no one has explained how or why the universe would split in the first place, or how we would detect it. It may be a clever interpretation of the math, but so far, it remains an interpretation, one possible story we can tell about what the math means. In practice, the standard Copenhagen interpretation of quantum mechanics simply says that when we measure a quantum system, its wave function collapses to a single outcome. The many worlds view skips the collapse, insisting all outcomes happen but in separate worlds. Other interpretations of quantum theory exist too. For example, the de Broglie-Bohm pilot wave theory describes particles guided by invisible waves. Some say this also implies hidden, parallel realities, though in a different way. But even there, physicists don't claim there's evidence you could visit another world. For now, experimental results are the same under all these interpretations. One person might think a wave function collapse is occurring. Another might say, yes, but that just means a new universe was created with the other result. Both interpretations make the same predictions for laboratory experiments. No experiment so far has been able to favor one interpretation over the others. So, quantum physics can allow for parallel worlds, but it doesn't force us to conclude they do exist. It's one possible story to explain quantum oddities. Beyond the quantum realm, other ideas about a multiverse come from cosmology. According to the theory of cosmic inflation, right after the Big Bang, our universe expanded extremely rapidly. Some versions of inflation suggest it was not a one-time event. There could be an endless, eternal inflation process, spawning an infinite number of bubble universes, each like its own Big Bang. In this picture, our universe is just one bubble in a vast froth of bubble universes. Each bubble might have different physical constants or laws. Only those rare bubbles where the constants happen to allow galaxies and life would contain observers like us. Famous physicists like Stephen Hawking and Alan Guth have argued that there is theoretical justification for this cosmic multiverse idea. Guth, who pioneered inflation theory, and Hawking later suggested that the math of inflation naturally leads to many universes. So far, we can't see these other bubbles. They would be far beyond our observable horizon, expanding away faster than light. If you tried to travel toward a neighboring bubble, you'd never reach it because the space between us would stretch faster than any ship can travel. And even if by some miracle, bubbles could collide early in the universe's history, the best we might do is look for faint scars of such collisions in the cosmic microwave background radiation. In fact, researchers like Rangaram Cherry have looked at data from the Planck satellite and found some weird spots on the sky that they speculated might be signs of a collision with another universe. It's an intriguing hint, but far from confirmed. Another idea is simpler, but just as strange. If the universe goes on infinitely in all directions, then there are only so many ways particles can be arranged. Eventually, with infinite space, even the exact same arrangement of particles could repeat somewhere, meaning there might be a region of space billions of light years away that is essentially identical to ours, with a doppelganger of you repeating your life choices. On the other hand, if space is finite as most think, this duplication probably doesn't happen. In summary, science has not proven that parallel universes exist, but it takes the idea seriously enough to study it. Many worlds and multiverse theories emerge naturally from some equations, so physicists explore their consequences. Some scientists even run clever computer analogs to see how bubble universes might collide, looking for any possible signature. Jonathan Braden, a cosmologist mentioned in Quanta magazine, admitted it's a long shot, but he still searches for any clue that could turn this untestable idea into something observable. At the end of the day, the question, are parallel universes real, remains open. Quantum physics allows them under certain interpretations, but no experiment has shown they are real. It's a brave hypothesis and a great mystery. If every quantum possibility does indeed play out, the cosmos would be unimaginably vast and strange. If not, then we'll have to find another way to explain quantum strangeness. Either way, the adventure of discovery is what matters. If this journey into parallel worlds and quantum mysteries excited your imagination, please like this video and subscribe for more mind-expanding science stories. I love reading your thoughts, and I promise to reply to every comment one by one. Let me know in the comments what you think. Do we live in a multiverse of infinite realities, or is this just a beautiful but unproven idea? Thanks for watching. And keep looking up at the stars. The answers are out there.